What if I told you that the Big Bang was never actually an explosion? When you hear that name, you imagine something bursting in space, like a giant firework. But that is exactly where we are wrong. It did not explode in space, simply because space did not exist yet. The Big Bang was the moment everything began. Space, time, energy, and matter. Everything was packed into an infinitely dense and hot point. Then something happened. But there was no air, no vacuum, and above all, no outside. It was space itself that began to expand. Most people think the universe is expanding into an infinite void. Wrong. The universe is not going anywhere. It is simply creating more space within itself. Imagine dots drawn on a balloon. As you blow it up, the dots move apart. They are not traveling across the surface, it is the surface between them that is growing. That is exactly what is happening today. Galaxies are moving away because the universe is still stretching. But then, what was there before? The answer is haunting. Maybe before does not exist. Asking what came before the Big Bang is like asking what is north of the North Pole. It makes no sense because time was born right there. So, can you even imagine absolute nothingness?
What if I told you humans are finally heading back to the moon? 50 years after the last Apollo mission, everything is about to change. It's called Artemis II, the first crewed mission of the new lunar era. 4 astronauts inside the Orion capsule will push further than ever before. But here's the catch: they won't land. They'll perform a high-speed loop around the moon using gravity to slingshot back to Earth. This is the ultimate stress test. If Artemis II succeeds, Artemis III will put boots back on the ground, and this time we're staying. Lunar bases, space stations, and a bigger dream. The moon is just the pit stop. The real destination? Mars. This isn't just a comeback, it's the start of a new age. Have you ever heard of solar storms? They aren't like the rain or wind we have on Earth, but colossal explosions of pure energy. Imagine billions of tons of charged particles blasted into space at incredible speeds. It all starts on the sun's surface, with flares and coronal mass ejections. But how long does it take for this energy to reach us? There's a key distinction to make. Light and radiation travel at the universal speed limit. If the sun emitted a flare right now, we would see it on Earth in about 8 minutes and 20 seconds. That's the time light takes to cover the 150 million kilometers between us and our star. However, the actual particles of the storm are slower. Even though they travel at millions of miles per hour, they take 1 to 3 days to hit our planet. When they arrive, they collide with Earth's magnetic field. This is where the magic happens. Earth's shield deflects these particles toward the poles, creating the breathtaking spectacle of the northern lights. But it's not just about beauty. The strongest storms can disrupt GPS signals, radio communications, and even power grids. We are currently in a phase of high solar activity, so get ready. The sun still has many stories to tell us. Many people think the sun is a giant ball of fire, but in reality, it's not burning at all. Fire, like a candle or a bonfire, comes from a chemical reaction between oxygen and fuel. Inside the sun, something much more powerful is happening. At the star's core, where temperatures exceed 15 million degrees, hydrogen atoms are crushed together by gravity. When they collide, they fuse to form helium. This process is called nuclear fusion, and it's one of the most energetic reactions in the universe. The sun isn't made of burning gas, but of plasma, matter so hot that electrons separate from atoms. A giant natural reactor that has been producing energy for almost 5 billion years, and will keep doing so for another 5 billion.